Good afternoon, students. In the next few sections, we're going to be talking about some of the most important things, in my opinion, that we're going to be learning this entire semester, even though they may not seem like a lot of quote-unquote chemistry to you. We're going to be talking about properties, which is definitely chemistry, but we're also going to be talking about a lot of math. We're going to be talking about something called significant figures, and we're going to be talking about dimensional analysis, which in my opinion is one of the most important things that we're going to be talking about this semester. And it is something that trips up many students, but it is going to be one of the most important things, I think, that I'm going to teach you this entire semester. And I hope that you're not offended. I am going to kind of teach it, I hope, in a kind of way that you may not have heard before if you've never been taught dimensional analysis before. But I want to teach it in a way that's going to get it really ingrained in your cognitive processes so that when it comes time and things get a little tougher in chemistry, because you're going to be using dimensional analysis many, many times this semester. And I want you to know it so well that it just becomes almost second nature to you. So I want it known so well that it really comes easily to you. So that's gonna come today as well in another video, but we're going to start it off easy with properties. And so we're going to be talking about physical and chemical properties and something called extensive and intensive properties. But properties are descriptors. We have properties. We talk about our eye color, our height, our weight, whether we're male, female, just all different kinds of things that describe us and our characteristics. And that's all properties are, is things that we use to describe. And in chemistry, we can describe things that are physical properties or things that are chemical properties. And so physical properties are things that describe the appearance only, things that do not describe that things that are going to change what the substance is. They're going to only describe the outside of the substance. So that is what a physical property does. It describes the outside, things like color, mass, odor, texture. These kinds of things are things that describe the physical properties of that. And those, one of the most important of all of physical properties, I think, is the state of matter. Whether something is a solid, a liquid, or gas is its physical state. And that is always and forever going to be a physical property. So you can change whether it's a solid or liquid or a gas by changing how much energy it has. We've already talked about that last video. You can change water into ice easily by putting it in the freezer, but you can get it right back by taking it out of the freezer and letting it melt again. And then you just have water again. And it did not change it from being water. It's still H2O. So, therefore, it is a physical change and a physical property. That gets us into the difference between whether something is a property or a change. If it describes it's a property, if you actually change something's state, let's say, from being a solid to a liquid, now that is a physical change. You didn't change what it is, you just changed what it looks like. Now you have a physical change. So in your homework, be expecting that. I'm going to ask you to make some judgments on whether something is a physical property or a physical change, a chemical property or a chemical change. Also, I want you to think about whether something is a intensive or an extensive property. And the difference between intensive and extensive is, does it, intensive properties, it doesn't matter how much of that substance that you have. Things like temperature. I don't know about where you're living right now, but outside right now at my house, it's kind of a dreary day. It's a little misty rain, and it's just not very comfortable. But it does not matter if I'm in a tiny little closet or if I'm in a very vast classroom. The temperature is going to stay the same. So temperature is what we would call an intensive property. If I have a tiny little cup of coffee, or if I am a huge big coffee drinker, and so I have a little bitty nice dainty little teacup of coffee, you see that I did not minor in art, or if I have a big whopping manly sized or big coffee drinker sized coffee, the temperature of this coffee, if I were to stick a thermometer down inside this one and a thermometer down inside this one, if they're at the same temperature, it doesn't matter how much it has in it. That is an intensive property, okay? The amount of the substance that you have does not matter. Intensive properties are like that. Things like temperature, color, whether it's a solid, a liquid, or a gas, it doesn't matter if you have a tiny little teaspoon of ice or a huge big chunk of ice, it's still going to be a solid. These are intensive properties. Now, extensive properties, the amount of the matter that you have certainly matters. So if I weigh each of these 2 cups of coffee, then they're going to weigh different amounts. They may not have a different temperature, but they're going to weigh different. So mass is what we would call an extensive property. Extensive properties do depend on how much of the substance that you have. So please make sure that you have that in your head. Intensive, it does not matter how much of the matter that you have. Extensive, it does matter. Things like mass, volume, those kinds of things are extensive properties. Well, let's go to chemical properties now. We talked about physical properties, things like melting. Point is a physical property. If we have changing from liquid to solid, now we are freezing, so we have a physical change. If we go from ice back to liquid, now we are melting, so now we have a physical change again. So the temperature at which that happens is the physical property, the actual going from solid to liquid, that's a physical change. Let's talk at the other end of the spectrum now. Let's talk about chemical properties. Chemical properties are those that describe how a substance can change or go from one thing to another. For instance, the fact that oxygen will burn is an example of a chemical property. Another example that I might choose to give you is acid. Now, a lot of you expressed either by email or in person or by phone to me your concern with these labs. So let's talk about them just for a minute. You all are going to be getting labs in the mail to you, and some of them are going to have acids in them. And you're like, oh my goodness. And I have to say that I was worried about that too. But I want you to think about something with me. We digest food, our bodies do. There are miraculous and wonderful things our bodies are. How do our bodies digest food and get rid of the food? And it begins as soon as we start chewing. If we chew, and I had a good salad for dinner last night, and I put me some great, awesome vinaigrette on there, raspberry vinaigrette. It was so delicious. And it had that vinegar in there, and vinegar is a type of acid. And so as I was eating my delicious salad, that acid already was starting to work. And that acid began to break down the little molecules that were in that salad. And also there were some tomatoes in that salad and some carrots and some other delicious things. But that acid was already starting to do its work and breaking down the food and the molecules that were in it. And then as it entered my saliva, saliva has those other things in there, including little acid molecules, and then it goes on down into our esophagus, and then it goes into our stomach, which has what in it? Acid. What kind of acid? Hydrochloric acid. The same exact kind of acid that you're probably going to be getting in some of these kits that are coming to your home. Now, how is it going to be coming to your home? I'm not 100% sure, but I'm willing to bet that it's probably going to be coming in a plastic bottle. Now, one of the properties of acid is that it will eat through and chew up things like rock, metal, and our food, but it will not eat through plastic, paper, or glass. Is that not awesome? A chemical property of acid is that it will break down and dissolve flesh, food, and if we eat too much acid or we worry too much and our bodies produce too much acid, then we can get an ulcer, which is an ulcer is just when our bodies do produce too much acid and it begins to eat a little hole, which is, I know, not very nice to talk about in a chemistry classroom, but that's exactly what it is. That's what an ulcer is the body's producing too much acid. The hydrochloric acid is eating a little too much through our stomach lining, and so how do we combat acids? With bases. So eat your little baking soda. That's a base, and that'll take care of the problem. But a chemical property of acids is that it will digest or dissolve or eat through food like meat, like salads, and break them down. Also rocks. Geologists will take a little plastic bottle of acids with them, pour it on some rocks to determine which rocks have different properties in them that they want to know, because acids react with certain rocks, but it will not eat through plastic or glass or paper. Pretty awesome. Now, that's chemical property. Chemical property. When that acid actually does react with that salad or that rock or that metal, then that is a chemical change. When that oxygen that's on here is talking about does burn, that is a chemical change. The fact that oxygen will cause burning, that is a chemical property of oxygen. When it actually does the burning, that's the chemical change. So please make sure you understand that difference. Okay? All right. And then we just talked about, I believe we already talked about, as soon as this next slide comes up, it's taking forever on this, the difference between extensive and intensive properties. Make sure you get that. Extensive, it does depend on how much of the matter. For example, if I tell you I have 12 pencils, that is an extensive property. Intensive, it does not matter. It's 20 degrees outside. It's going to be 20 degrees, or the melting point of water is an intensive property. Freezing point, those kinds of things. It doesn't matter if you have a little bit or a lot of it. It is the same. Okay? So make sure. All right. I believe that's all for now. I'm going to make you another couple of videos and call it a day.